What if the US Navy had a carrier you couldn't see? Because it was underwater. Not a submarine, not a carrier. Something in between. A submerged base designed for modern war zones. Invisible to satellites, unreachable by missiles, and always in position. Because when your rivals build anti-ship missiles the size of school buses, floating a billion-dollar carrier into range stops being bold and starts being dumb. So here's what happens when the US Navy decides to hide its next carrier under 500 meters of saltwater. Let's dive in. What is a stealth carrier? The US already has aircraft carriers the size of cities, but what if the next one didn't float? That's the idea behind a stealth carrier, a submerged launch platform built to deploy drones, loitering munitions, and surveillance systems from beneath the waves. It doesn't need a runway, it doesn't need escorts. It moves silently, strikes remotely, and disappears. And the parts are already in motion. Blackwing UAVs, launched from submarine torpedo tubes, unfold and fly 30+ miles for ISR and targeting. Razorback UUVs, autonomous underwater drones that map, scan, and return, all without surfacing. DARPA's Cormorant, a drone designed to launch from beneath the surface, fire up a jet engine, and fly. Virginia-class Block 5 submarines, now fitted with 87-foot vertical launch tubes, originally for Tomahawks but sized for next-gen payloads. ISR pods, drone swarms, or loitering weapons. None of these systems are labeled stealth carrier, but the direction is obvious. Because surface carriers are becoming liabilities. China's DF-21D and DF-26 carrier killer missiles can strike from over 1,500 miles away. Hypersonics like Russia's Zircon move too fast for current defenses, and satellite imaging, military or civilian, can track carrier groups in near real time. In short, if a carrier can be seen, it can be hit. If it can be hit, it can be sunk. And if it's a $13 billion Ford class with 4,500 crew on board, one strike becomes a national disaster. A stealth carrier changes that, and the idea isn't new. In World War II, Japan built the I-400 class, massive submarines with 100-foot hangars that carried 3 float planes. With a 37,500-mile range and onboard catapults, they could launch surprise airstrikes from the middle of the ocean, too late to change the war, but decades ahead of their time. The modern version keeps the core logic and replaces everything else. Planes become autonomous drones. Catapults become pressurized underwater tubes. Crews of hundreds become 30 sailors, or none at all. Of course, real challenges remain. Power, autonomy, underwater comms, and logistics, all harder underwater than on land. But none of them are unsolvable. They're being worked on right now, and the funding shows it. Over $7 billion invested into directed energy and autonomous system development. $274 million awarded for Boeing's Orca Stealth UUV, already in low-rate production. Dozens of U.S. patents filed for drone capsules, underwater launchers, and seafloor payload pods. The Navy may not be ready to unveil a finished stealth carrier, but the blueprint is real. Power, endurance, and staying hidden. Let's start with power. Every U.S. Navy submarine since the 50s runs on a nuclear reactor. It doesn't need oxygen, never needs refueling, and can operate underwater for 25 to 30 years without surfacing. For a stealth drone carrier, a nuclear core would provide enough juice to launch UAVs, run sensors, recharge drones, and keep the whole system moving, quietly for months at a time. The downside? Nuclear is big, hot, expensive, and harder to miniaturize. If you want to build something smaller or even uncrewed, the Navy has other options. Diesel-electric systems are proven, reliable, and compact, already used in subs around the world. In this setup, the vessel charges batteries while near the surface, then runs silently on battery power when submerged. It's good for short bursts of stealth, but sooner or later it has to come up for air. That's a problem when you're trying to be invisible. Hybrid systems offer a middle ground. Boeing's Orca XL UUV, for example, uses diesel generators plus high-capacity lithium-ion batteries. It's 50 feet long, fully autonomous, and can operate for months without human contact. The range? 6,500 nautical miles. The Navy already spent $274 million building it. Think of it as a prototype for what an uncrewed stealth carrier could look like. Still, long-term autonomy needs power that lasts. That's where DARPA's weirdest ideas come in. They've explored ocean thermal energy, using the difference in temperature between deep and shallow water to generate electricity. One prototype cycles up and down the thermocline, storing power as it moves. Another concept uses wave energy or even slow underwater gliders that charge themselves over time. These systems don't produce much power, but they're quiet, untraceable, and potentially limitless. Now layer in endurance. Modern nuclear submarines can stay submerged for 90+ days. Not because of fuel, but because of food. The limiting factor is the humans on board. A stealth carrier, especially an uncrewed one, wouldn't have that problem. No oxygen to recycle, no crew to feed. That means it could sit in place or cruise slowly through contested waters for half a year or more. But autonomy comes with risk. If something breaks, there's no crew to fix it. If communications go down, there's no one to reboot. And undersea communication is its own nightmare. Radio signals barely penetrate saltwater. At best, you get 300 bits per second over acoustic signals. So, unless the system periodically surfaces or trails a long antenna, it's basically flying blind. There's also the thermal problem. Submarines generate heat. Heat leaves a signature, and heat from a nuclear reactor or high-capacity electronics could give away a stealth carrier's location if not managed properly. That means advanced cooling systems, silent pump technology, and thermally shielded hull designs, not all things the Navy's been refining for decades. So can a stealth carrier really stay hidden? Yes, if it balances power, endurance, and silence. Hybrid systems like those in the Orca might be the bridge until technology catches up. The platform's already in motion. Over the last decade, program by program, the US has tested everything you'd need: underwater launch, recovery, long-range autonomy, and modular payload delivery. Submarines like the Virginia-class are already launching Blackwing UAVs through 3-inch torpedo tubes. These are compact ISR drones, folded to fit in launch canisters, then unfolding to a 1.5-meter wingspan and flying up to 30 miles. They scout, relay targeting data, and quietly extend a sub's awareness without exposing it. Then there's Razorback, a 600-pound UUV deployed from torpedo bays. It autonomously maps seafloors, monitors acoustics, and can even act as a communication node. A stealth carrier wouldn't just need weapons, it would need situational awareness. Razorback fits that role. Even airborne launch has been tested. DARPA's Cormorant concept showed how a drone could be ejected from a submerged launch tube, break the surface, ignite a jet engine, and fly. It was recoverable, shaped for pressure depth, and fully self-deploying. The project didn't reach full development, but its patent and blueprints live on, ready to be revisited when needed. Meanwhile, deeper inside the hull, Virginia Payload Modules, VPMs, offer vertical launch bays 87 feet deep, each holding 7 cruise missiles or whatever else can be packed into a tube that size. These weren't designed for drones, but they don't care. Loitering munitions, ISR pods, decoys, all fit. A stealth carrier wouldn't need a hangar, it would need tubes like these. But it doesn't stop with the sub. DARPA explored ways to externalize the carrier entirely, turning the ocean floor into an arsenal. Hydra was one concept. Deployable pods that sit underwater and release UAVs or UUVs when remotely triggered. Upward falling payloads, UFP, took that even further. And above it all is Orca, the first true prototype of a long-endurance, uncrewed underwater mothership. Boeing's XLUUV is 85 feet long, fully autonomous, diesel-electric powered, with a 6,500 nautical mile range and a 34-foot payload bay. The Navy's ordered 5. Cost? $274 million. And while it isn't armed today, it's modular, designed to carry sensors, UUVs, even smart mine dispensers or loitering drones. Put it together, and the architecture starts to show itself. What China and Russia are building below the surface. While America quietly builds modular systems, China and Russia are shaping their own subsurface strategies. China's military doesn't talk about stealth carriers either, but its projects line up like puzzle pieces for that exact idea. One of the most revealing is Feiyi-1, a dual-mode drone that launches from underwater and converts to flight mid-mission. In tests, it rose from below the surface, extended wings, and climbed to 10,000 feet, then splashed back down to relaunch. At the same time, satellite imagery shows large uncrewed undersea vehicles, XLUUVs, under construction at Hainan's naval yards. Estimated size 30+ meters long. That's big enough to house serious payloads. Not just sonar or mines, but loitering drones or strike packages. Then there's the defensive side, the so-called underwater Great Wall, a coastal barrier of seabed sonar, hydrophones, and passive acoustic sensors built to track foreign submarines. It's not a launch system, it's a tripwire, meant to counter exactly the kind of stealthy platform the US is now shaping. And China's interest in energy weapons overlaps too. In 2025, the military unveiled LY-1, a turreted high-energy laser system mounted on a truck and amphibious ship. Some analysts suggest it could be adapted for underwater use, potentially as a close-in weapon against drones or sub-launch threats near naval bases. Russia's take is louder and heavier. The centerpiece is Poseidon, an unmanned, nuclear-powered underwater drone designed for strategic deterrence. At roughly 24 meters long, Poseidon is one of the largest torpedo-like weapons ever built. Russia claims it can cruise at over 100 knots, travel intercontinental distances, and carry a multi-megaton nuclear warhead designed to detonate offshore, creating massive shockwaves and radioactive tsunamis aimed at coastal targets. Poseidon rides on Belgorod, the longest submarine in the world. 600-plus feet long, equipped to carry multiple UUVs and act as an undersea mothership. Belgorod also supports deep-sea operations, tapping cables and deploying mini-subs. It's not stealthy, but it is functional. Russia also built a network of undersea sonar posts called Harmony, positioned in Arctic waters to track NATO submarines, and it's been testing laser dazzlers like Zadira, intended to blind enemy ISR assets. In 2022, Moscow claimed to have used Zadira in Ukraine against drones. Possibly true, possibly bluff, but either way, a signal. They're not carriers in the classic sense. They won't launch jets. They won't host Top Gun. But if you like drone tubes, underwater patents, and billion-dollar platforms that ghost their enemies from 500 meters down, you're in the right place. Hit subscribe, stay submerged, and we'll keep showing you the tech no one's supposed to talk about.